Example 6, the integral sine x all over cosine squared of x dx. Okay, so before I start this one, we know that there is an inverse relationship between derivatives and integration, antiderivatives. So let's go through all the derivatives for the trig function. Trig function, so the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine x. The derivative of tangent of x is secant squared x. The derivative of secant of x is secant x tangent x. The derivative of cosecant of x is negative cosecant x cotangent of x. And then finally, the derivative of cotangent of x is equal to negative cosecant squared of x. And notice that derivatives or antiderivatives would be going back this way. So if we can get this function to look like one of these functions, then we can find the antiderivative very easily. So back in trig, you did a lot of trig identities. So that's kind of what we're going to do here. So we're going to rewrite this as, let's start with rewriting this as sine of x times 1 over cosine squared x dx. That's an identity. Then I can write this as sine x over cosine x times 1 over cosine x dx. This here becomes that squared. And then this would equal tangent of x, and this would equal secant of x, which now this guy is this one here, which means the antiderivative of secant x tangent x is going to be secant x. So this would be equal to secant x plus c. Hopefully that makes sense. So hopefully you could see here as well, if you know your derivatives really well, finding the antiderivative is basically undoing, taking the inverse. So it should be very helpful. All right, example 7, let's try some of these. So part A, I'm going to rewrite this integral as 2 times the 2 times x to the negative 1/2 dx, and then that is the same as 2 times x to the negative 1/2 dx. Here I'm going to use the power rule to find the antiderivative. So it's going to be 2 times, and then it's going to be x to the negative 1/2 plus 1 all over the negative 1/2 plus 1 plus c. So this would equal 2 times x to the 1/2 all over 1/2 plus c. And then this would end up being 2 times 2 times x to the 1/2 plus c. So finally this equals 4x to the 1/2 plus c. Let's try b. For b, the first thing we're going to do, we're going to expand this. So we've got t squared plus 1 times t squared plus 1 dt. So I'll multiply here. I'm going to get t to the 4th plus t squared plus t squared plus 1 dt. So this would be t to the 4th plus 2t squared plus 1 dt. Now I can take the antiderivative power rule for all of these. So it's going to be t to the 5th over 5 plus 2 times t to the 3rd over 3 plus 1 would become t to the 1st power plus c. Let's try c. So first thing I would do here, I'm going to divide, simplify these. So this would be x plus 3x to the negative 2nd dx. Then this would end up being x to the 2nd power all over 2 plus 3x to the negative 1st all over negative 1 plus c. So this is going to be x squared over 2 minus 3x to the negative 1st plus c. Finally, part D, let's rewrite this as x to the 1/3 power times x, the quantity of x minus 4 dx, and then distribute here, and we'll get, add those exponents, be x to the 4/3 minus 4x to the 1/3 dx. Take the antiderivative. If I add 1 to 4/3, that's going to be x to the 7/3, all divided by 7/3, minus 4 times x to the 4/3 divided by 4/3 plus c. So this would equal 3/7 x to the 7/3 minus 4 times 3/4 times x to the 4/3 power plus c. So this would equal 7/3 x to the 7/3 minus 3x to the 4/3 plus x. Or I'm sorry, plus c.